Hello, hello. We are back with Chapter 10, Probability, focusing on Lesson 2, Experimental Probability. So this is the guided practice. I want you to go ahead and find the experimental probability. Write your answer as a fraction in simplest terms. That's really, really important. I'm going to highlight that. Write your answer as a fraction in simplest terms. Perfect. So I want you to go ahead and get started on this first page. Like I said, this is the guided practice, so I want you to work out these problems on your own. Make sure you show all your work like we were doing in the previous video. And then when you get done, we'll go over the answers. Okay, so here's our friend the pause dragon reminding us to pause our device. And when you get done, go ahead and press play and we'll go over the problems and see how you did. All right. All right, we're back. Let's see how you did on problem number 1. So what it states is Jolene is playing basketball. She scores on 11 out of the 15 baskets she shoots. What is the experimental probability that Jolene will get a basket on the next shot? So, probability of getting a basket is going to be the number of made baskets out of the total number of baskets shot. Okay, so the total number of made baskets would be she scores 11, so that means she made 11 and she shot 15. So there you go. There is our experimental probability for the number of baskets that she made. Now part B says, what is the experimental probability that Jolene will not get a basket? So if we know the number of baskets that she will get, if we want to know the number of, well, let's call it misses, we're going to take 1 and subtract it from the total of times that she made it, which was 11 out of 15. That's a pretty good shooter, okay? I'm just going to put it out there. So we need to make that one a fraction. We're going to get a common denominator, which is going to be 15. So I'm going to multiply the top and the bottom by 15, which is what am I going to end up with? I'm going to end up with 15 over 15 minus 11 over 15, which is going to give me 15. We have a common denominator now, so we just go 15 minus 11, which is 4/15. So if you got that for the number of made baskets and the number of misses, if you got 11 out of 15 for the number of 11/15 for the number of makes and 4/15 for the number of 50 for blah, 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 blah. I'm sorry, she's having technical difficulties speaking. She'll momentarily be back with us. Excuse me. Okay. I'm going to try this again. If you got 11/15 for the number of makes that she made and 4/15 for the number of misses, great job. Okay, let's go on to the next problem. Problem number 2. Jamie is playing baseball. He gets a hit 7 out of 9 times at bat. What is the experimental probability that Jamie will get a hit his next time at bat? Cool. So we're going to say, what's the probability of a hit? And that's just going to be the total number of hits over number of times at bat. So the total number of, it's going to be over the total number of times at bat. Okay, so the number of hits, he gets a hit 7 out of the 9 times at bat. So 7 hits goes on top, and there was a total of 9 times at bat. So there you go. There's our experimental probability for the number of hits, 7/9. Okay, let's move on to B. What is the experimental probability that Jamie will not get a hit at the next time at bat? Okay, so will not. Okay, so that means we're going to be doing that 1 minus thing. So what's the probability of no hit? We're going to go 1 minus the number of hits, which is 7/9. And we're just going to do this math, so we need to go ahead and make that a fraction. That's 1 over 1, right? We need to get a common denominator, which we're going to multiply the top and the bottom by 9, which is going to leave us with 9 over 9 minus 7 over 9, and we subtract. 9 minus 7 is 2 over 9. Boom, there we go. So it's 2/9 is the probability that he will miss the next time at bat, or not get a hit the next time at bat. So if you got both those right, awesome, awesome, awesome. Okay, let's go on to problem 3. Problem 3 says Luann is practicing for an archery tournament. She hits the target 7 out of 11 times. What is the experimental probability that Luann will hit the target on the next shot? All right, cool. So we're trying to find the probability that she will hit it. Okay, so that's going to be the number of hits over the total number of shots. Yeah. Okay, let's go ahead and fill in the information. The number of hits, she hits the target 7 times out of 11. So it's going to be 7 out of 11, and that is in simplest form. So there's our probability. And then B says, what's the experimental probability that Luann will not hit the target on the next shot? So that means I'm going to say it's a miss. Not hitting would be missing it, right? So we're going to go 1 minus the total number of times that she hits it, 7 over 11. And we're going to make this into a fraction, 1 over 1. We need to get a common denominator. Our common denominator needs to be 11, so I'm going to multiply the bottom and the top by 11. That leaves me with 11 over 11 minus 7 over 11, which when we're subtracting fractions, we just subtract the top. 11 take away 7 is 4 over 11. Boom. You got all those right? Awesome, awesome, awesome. Okay, let's go on to the next page. And what I need you to do is go ahead and try problems 4 and 5. Find the experimental probability. Write your answer as a fraction, as a decimal, and as a percent. So go ahead and pause your device, work out problems 4 and 5. When you get done, press play, and we will see how you did. All right, cool. All right, we're back. Let's see how you did on problem 4. Okay, so problem 4 states a batter gets 6 hits in 12 times at bat. What is the experimental probability that she will get a hit in her next time at bat? Okay, cool. So we're finding the probability of a hit, which is going to be the number of hits over the total number of times at bat. Okay, I kind of paraphrase there. Okay, so the total number of hits is 6. The total number of times at bat would be 12. So 6 over 12. And then we just need to simplify this, right? So what goes into both 6 and 12? I'm pretty sure that 6 does. 6 goes into 6 one time. 6 goes into 12 2 times. We're left with 1/2. All right, cool. So that is our probability. Oh, what do we have to do it as? A fraction, as a decimal, and as a percent. So I'm going to say the probability of getting a hit is equal to 1/2. All right, all right, all right, all right. Let's go ahead and convert this into a, how are we going to convert this into? Convert it into a decimal, right? We can just divide this. 1 divided by 2. Okay, do the long division. Does 2 go into 1? No, it does not. Does 2 go into 10? Yes, it does. 5 times. 5 times 2 is 10 with no remainder. Yeah. So the probability of a hit as a decimal would be 0.5. All right, all right, all right. And if we want to take that and convert it into a percent, we're going to take that 0.5 and move it over 2 places to the right. So that would be 1, 2, right? Which would give us, that would equal 50%. And we put a 0 there, right? So it would be, yeah. So the probability of a hit would equal 50%. So that is in fractional, decimal, and percent form. Boom, there you go. If you got that right, awesome, awesome, awesome. Okay, let's go ahead on to problem 5. It says a goalie blocks 16 out of 20 shots. What is the experimental probability that he will block the next shot? All right, cool. So we're trying to find the probability of a block. So we're going to take the number of blocks over the total number of shots. Okay? So the total number of blocks is 16 out of the total number of shots would be 20. Then we just need to go ahead and simplify this. So put it in the lowest terms. Is there a common factor between 16 and 20? I would say yes, sirree. I don't know why I just said that. Okay, 4 goes into both. 4 goes into 16 4 times. 4 goes into 25 times. So we end up with 4/5. So that means the probability of a block equals 4/5, and that's in fractional form. Now we need to go ahead and turn that into a decimal. So I'm just going to go 4 divided by 5. 5 does not go into 4, but 5 does go into 40. It goes in there 8 times. 8 times 5 is 40. 40 take away 40 is 0, and boom, there we have it. So the probability of a block, as far as a decimal goes, is 0.8. And then the last thing, we need to go ahead and convert that into a percentage. 0.8, we go ahead and move that decimal over 2 places to the right. 1, 2, there's our new decimal. We put in a 0, and we get 80%. So the probability of a block is equal to 80%. Okay? And if you got all of those right, yokinekimashita, you did a great job, and we will see you next time. Goodbye.